In physics, vector mathematical operations are not just algebraic tools, but they directly represent real physical actions, measurements, and laws of nature. The most common vector mathematical operations are vector addition, vector subtraction, two kinds of vector multiplications, which are dot product and cross product, and multiplication of a vector by scalar. Vector division operation does not exist. Let's talk about vector addition with the help of an example. Let's say we walk 3 meters east and then 4 meters up north. Our net displacement is 5 meters northeast, and we get this net displacement by performing vector addition. Vector addition represents the net effect of multiple physical quantities acting together. Physically, nature always responds to the resultant vector, not individual ones. Next, as an example of vector subtraction, let's say we play a tug of war over a ball that you're pulling to the right with a 12 newtons force, while I am able to pull the ball to the left with only 10 newtons of force. Of course, you will bring the ball home because you're exerting 2 newtons more force than I am. So vector subtraction describes the difference between two vector quantities, often representing change or relative motion. Physically, vector subtraction answers how much and in what direction did something change. Moving on to dot product. The dot product basically measures how much one vector acts along the direction of another. If two vectors are perpendicular to each other, they would have no component along the direction of the other. Their dot product would be zero. They would have no physical effect on each other. Moving on to the cross product, also known as vector product. The cross product is a mathematical operation between two vectors that produces a third vector that is perpendicular to both vectors. The cross product measures the tendency to rotate or twirl. Lastly, a vector can be multiplied by a scalar to change the magnitude of vector without changing its direction, unless the scalar is a negative, in which case not only the vector's magnitude is scaled, its direction is also reversed.